Hey, hi everyone. So this is just a detailed explanation of a research paper which is written by uh, Cleveland and Mcgill. So the topic is the graphical perception and theory, experimentation and application to the development of graphical methods. So when we talk about the BI tools and the different type of visualizations, so there are some visualizations which uh, human brains don't easily understand, and we have to put a lot of efforts to understand it, right? So that part is actually called by the author as the elementary perceptual task. So the a graphical form that involves elementary perceptual tasks that lead to more accurate judgment, and the another graphical form when it will result in a better organization and increase the chances of correct perception of pattern and behavior. So what they have done is they have identified around 10 different graphs, and they have rated it, like they have organized in such a way that okay, so these are some graphs which, if a human brain, if a person sees to it, then he can easily understand, while there are some graph which we might need to put more efforts in understanding. So okay, so first let's see which are those 10 graphs. So first is the sample distribution plot. So the sample distribution plot is similar to this scatter plot, which is shown over here. Second is the bar chart, which we used to see. Okay, so universally these are the bar chart that are accepted, but there are some bar charts which have lesser width, or the area also keeps on changing. These are the bar charts. These are only shown in the research paper, but not universally accepted. Then comes the pie chart, which which all are aware of. Then the divided bar chart. So these are the divided bar chart. Uh, in the real world, we used to call stacked bar chart and cluster bar graph, but over here they call the stacked bar chart as the divided bar graph, and the clustered bar graph as this thing, group bar chart. Then comes the statistical map with shading. Okay, so this is how, let's say, the map of US and the murder rates are shown in the form of shades, different form of shades. Then comes the curve different charts. So these are two different curves, and what? So this is a curve of export and import to and from East Indies from 1700 to 1780. So what a human brain tendency is to do is to subtract both these values and find the net import, right? So then the next is Cartesian graph scatter plot. So we generally called scatter plot, but in this research paper they have called it Cartesian graph. The next is triple scatter plot. So this is nothing but also kind of scatter plot, but the third dimension is the area in the circle, right? So the third dimension also represents something. Then the last two are the volume chart and juxtaposed Cartesian graph. So volume graph, like the volume will represent the unit, the quantity, and juxtaposed bar graph, like in Python we used to see the pair plots, right? So this is similar to it. So the scatter plots are compared with each other and placed together. Now these are the 10 visualizations identified by the author, and what is the elementary task in each of them. So how does a human brain read it? So the first is the sample distribution function plot. So over here we'll see the x and y coordinates of all these points, and find to see how the position is. So we'll either compare with some scale, right? So there has to be some reference through which we will compare this. Second is the bar chart. So as we said, the bar chart, these are the ones which are universally accepted, but here there are some bar charts wherein they have divided, they have changed the widths. So you just don't need to compare just the length, but also the area, the width also comes into picture. That's what the author has said. The third thing is pie chart. Usually we think that it's just the angle, but sometimes the area and the arc length also comes into picture. Then it's the divided bar chart. So yeah, we discussed it, right? The divided bar chart and the statistical map with shading. So over here, the thing is like the shades are given based on the legends, like the scale that we define. And in the curve different chart, the elementary task would be to like our brain will calculate the difference between them, and then it will be identifying that okay, during which years the gain was more. And the Cartesian scatter plot, over here again we will think of whether it's a linear curve or non-linear curve, right? So it will judge the pattern. And the triple scatter plot, over here our brain will think of the third variable, that is size. All are circles, and circles also overlap with each other, but the size keeps on changing. It seems like the volume we can easily understand, right? And the next thing is uh, we'll judge the positions along the non-aligned scales of these scatter plots. Now what the author has done is they have created an hypothesis, like how can we make the representation of these visualizations better to understand. Okay, so how should we select it? So let's first start with the pie chart. So in the pie chart, we're able to see A, B, C, D, E. So D is the highest over here, B might be the second one, and C might be the third one. So, but that isn't like we don't directly understand that. So there is a bit of efforts that we need to put over here. So that is the reason author is suggesting that instead of using pie chart, you should always prefer bar chart. So in bar chart, we can easily calculate the length, right? And we can also see the order of this. So over the angle, the length is preferred. Remember this. Over the angle, length is preferred. Next is divided bar chart. So in the divided bar chart, again, these are the length that we need to see. Alright, so instead of the author is saying that instead of the length, a human brain can easily judge the position. Right, so instead of divided bar graph, you should always prefer the dot charts. So these are the dot charts. Yes, so this is how uh, the same graph can be represented in the form of dot charts, wherein you can see that okay, so A5 is the highest, A4 is the lowest. And there is some order in this, so we don't need to actually see the length, but only the positions. Right. Third is the statistical map with shading. Now let's see what is the issue with this graph. Now let's say this is in the Texas. Uh, what a non-technical person will, how a non-technical person will see this graph. So firstly, the states wherein this mesh size is very less, like these are very close to each other, a human brain will think that okay, it is more dense, the value of this state should be more. And wherein the graphs, like in this North Dakota, South Dakota, the mesh size is bigger, so the value will be less, and obviously that's the same thing represented by the legends. So that is the first thing that we need to calculate. Second is we also need to see the shapes of the states. Okay, that also we need to think of. And another thing is, if you see the data set, the value of the murder rates in North Dakota and South Dakota is different. However, the mesh size is almost similar. Reason being the scale that is defined. Let's say if we change the data set, okay, but again the scale remains the same, so we might need we might be able to see the same kind of patterns somehow. So instead of doing that, what the author suggested, that there should be rectangular frame. Yeah, so there should be a rectangular frame which should calculate the value. And also, as you can see, again the value of, like, we can't distinguish all this three, all this, like the entire group, right? It looks very similar. So what we said is, like, find the median and group all these boxes, like all these rectangular shapes. So what they've done is they've grouped all this value, like ranging from 0 to 4, they have given this shape, 4 to 8 they have given this shape, and it will be easy. Now to make this more easier, they have reduced the size of these boxes, right? So this, it is more like understandable. Then talking about the curve different charts, so the thing is, regarding that import export thing, where we need to think of what is the net import value over here, right? So instead of what the author suggested is, we just need to simply calculate the difference between them, both these values, and plot it against the same y-axis. Yeah, so here is how the curve they have suggested for the import export, right? And yeah, so what's the conclusion? So the conclusion is, uh, position. A human brain can easily judge the position of visualization based on the position rather than length, direction, angle, followed by area, volume, curvature, shading, and color saturation. So these are the 10 different element tasks that we came across. So yeah, that is all about the stuff that is the author explained in this research paper. Thank you.